this tutorial we're going to discuss about 8 elements array antenna design in CST, and this is our reference antenna, which is basically 4 elements array, and it is operating at 2.45 gigahertz, and it provides the gain of 10.9 dBi at 2.45 gigahertz, right? So this is a reference antenna, and we will further design its 8 element array in this tutorial. So if you have any confusion about the spacing between different elements and about the widths of different feed lines, then you can just watch our previous tutorials in which we have designed 4 elements array, 2 elements array, and even single elements design. And in these tutorials we have properly discussed that why we have taken different values for the width of feed line and the spacing between these patches, right? So the link of all these tutorials are provided in description. You can just watch if you have any confusion about its formulas, right? So now let's start its 8 elements array design. So first of all, from components you have to select the patch, because you have to just transform it, and you can just make a copy of these 4 elements, and you can just translate it either on the right side or on the left side of your previous design, right? So for example, if I want to place these 4 elements at the right side of my previous design, then I will just put the positive value here along the x-axis, right? So if I discuss about its gap or its spacing between the different elements, then I have already used the variable d, and that d is basically the gap, which is lambda by 4 or 14.58 between the elements, and that d contains the width of one patch as well, right? So for example, if I write simple d here, it means that this corner point will move to that corner point, because the value of d is equivalent to the gap plus the width of the patch, right? Because the width of the patch is 29, and the gap between these two patches is lambda by 4, and that is 14.58, right? So when I simply write d here, it means that this corner point will move toward that corner point, right? So just click on preview, and you can observe that that point is moved toward that point, right? So simply when I will further add d here, it means that another movement will be done, and this corner point will be moved to that point, right? So just click on preview, and you can observe these movements, right? So by adding simply d for the 3rd time, it will move toward at the corner of other patch, right? So you need just another d, and that d will move toward this corner to that point, right? And that will be the exactly point where I want to move these 4 elements, right? So that's how we can just copy these 4 elements, and we can just paste these elements at proper distance, right? So now in next step we have to define the 2 feed lines, right? So the one feed line between these 2 feed lines, and the last feed line will be the final feed line to provide the port, right? So now you have to basically define the feed line here, but as you know that we have already used the variables, and it will be difficult for us to find out the exact point. So just click on the patch, and as you know that you have already defined your feed line, right? So just you can check the feed line at this point, right? And you can just copy paste that point, right? So simply you can check the feed line, and that is basically the last feed line, and just double click on it, and its x min will be same as we want to define the feed line here, right? So we will exactly start the next feed line from this x min, right? So just copy this value, right, and you can just close it, right? So now it will be easier for us to define the x min of our newly defined feed line, right? So it will be our feed line number 11 because we have already defined 10 feed lines, right? So it will be named as feed line 11, and as you know that the x min point will be same that we have copied from our previous values. These are the different variables, right? So just copy this value and just paste it here, and now you have to further move it toward the positive x-axis, and now you have to find out the values along the positive x-axis. And as you know that the variable d is basically the gap between the two patches plus the width of the patch, right? So just count that how many gaps are there between these 2 points and how many patches are there between these 2 points. So it will be very easier for you to define the x max of this feed line, right? So let's count. For example, if I consider it as a midpoint, it means that this will be the half of the gap, right? And along that point, if I consider that point here, it means that this is also at the middle of these two patches, right? This feed line. So this is also a half gap. So half plus half gap will be one gap, and second gap, third gap, and fourth gap. It means that there are total 4 gaps between these two feed lines, right? And similarly, if you count the patches between these two feed lines, it means that 1, 2, 3, and 4. So there are 4 gaps and 4 patches, and as you know that this variable d represents the gap plus the width of the patch. So it means that if you simply write 4 times d, it means that you can easily achieve the total length, right, along the x-axis. So that's how you can define x min and x max values. Similarly, you can define the y min and y max values. And y min value is basically you have to proceed from this starting point, and that was the starting point. You will simply write minus L by 2, because along the y-axis that is basically 0 position, plus L by 2 represents the upper side of the patch, and minus L by 2 represents the lower half of the length of the patch, right? So minus L by 2 means that from 0 to this point, right? Simply, if I further subtract its length of feed lines, and so for length of feed line I have already defined the variable LF. So by subtracting LF we will approach to that point. And further, this is the width of feed line, and that feed line is represented with WF2, right? So I will simply subtract the width of WF2, and after subtracting WF2 there is further a length of feed line. So I will simply write minus LF, and we will approach to that point. Now there is an other width of feed line, and that width of feed line is represented with WF2. So after writing minus WF2 here, I will approach to the lower end of this feed line. And now there is an other length of feed line, so just write minus LF. So by writing all these values, you will approach to that point, right? So that will be the basically maximum point of length of feed line, right? So just select it and copy it and write it in the W max, while in W min you have to add further width of feed line. And as you know that if you have watched my previous tutorials, then that will be the width of feed line, and that is width of feed line for 70.7 ohms, and that width is represented with WF2. So we will simply subtract WF2 to add that point, right? So now just write the position 0.035 plus 1.6, that is the starting point, because 0.035 is the height of its ground, and then there is a height of its substrate, and now you will further add 0.035, and that will be the width of its patch. So same material will be used. Just click on preview, and now you can observe that you have exactly defined the feed line 11. Now you have to make just one change, and that change is you have to add the width here along the x max, right? So simply add WF2, right? Sorry, WF here to increase its length along the x-axis, right? So just click on OK, and finally now you have to define its last feed line, and for that feed line you have to find out the exact middle point, right? And that is the middle point where you want to define its feed line, right? So as you know that in this feed line, if you calculate or you can copy the starting point, right? So I have copied the starting point, right? So just close it, and now go to the modeling and just define the feed line 12, right? So it will be feed line 12, and now just put the copied value here in xmin, but just think that this starting point was basically going to start from here, right? And that is not exact middle point, right? So if I want to achieve its middle point, this is basically WF, and that is the starting point. So if I want to achieve its middle point, or if I want to obtain the value for the middle point, then I will just add half of its width, because in that feed line its half width is along the negative x-axis and half is along the positive x-axis. So if I want, I have the starting point along the negative axis, right? So if I want to achieve its 0 point, it means that I have to add simple if I have to add simple half of its feed line, then I will reach exact at the middle point here, right? So that's why I have simply added this point. But now I want to just reach that point, or you can say that at the middle point between these two patches, and you are now here at the middle point of this patch, and as you know that that half gap and this half gap will be equivalent to the one gap, and there is another gap. So there are two gaps and two patches between these 2 points. So it means that one gap and one simply width of patch is equivalent to the D. So if there are two gaps and two patches, it means that I have to add simply 2 times the D, and I will exactly at that point, right? And that is the central point, right? So simply I will just select all, and I will just copy and paste here. So that is the value of the reference to reach the middle point, right? But now as I want to add the width, and that width is represented with WF, and I would like to half of its width along the positive x-axis and half of width along the negative x-axis. So I will simply add plus WF by 2 along x max and minus WF by 2 along its x min position, right? So these are the exact values for defining the final feed line, and as you already know that minus L by 2 and then minus LF and then minus WF2. So minus L by 2, minus LF, minus WF2, and then minus LF, and then minus WF2, and then minus LF. So this is basically minus LF, minus LF, minus LF. So 3 times minus LF, and 3 times minus WF2, right? So we'll reach to the bottom of this feed line, right? So simply select all and just copy it and paste it, and now you have to add simple minus LF, which will be the length of the feed line for the final feed line, right, along the Y min point, right? So these are the different values, and if you have any confusion, then you can watch my previous tutorial. You can easily understand that why I have taken these variables and these values, right? So just add 0.035 plus 1.6, which is starting point, and just paste it along Z max, and plus 0.035, which is the basically the thickness of the patch, right? So just click on preview, and you can easily observe that these are the exact values, and this feed line is exactly at the center of this point, right? So now one more thing that I would like to add here is that you have to just copy the value of Y min, because now we have to increase the size of substrate and ground as well to the end point of this substrate. So that's why we have to just copy this Y min value, and we will simply change the size of substrate and ground to touch the endpoint position of this feed line, right? So we will simply click on substrate, and we will increase the size of substrate here, right? And we will just press OK. So now we have increased the size of substrate, and now we will also increase the size of ground as well, because you can check here that ground is not at the end point where our feed line is going to end, right? So that's why we will simply add the copied variable values, and that problem will be resolved, that our substrate and ground are exactly at the same end points where we have ended our feed line, right? So now one more thing that you must do before starting the simulation is that you have to increase the size of ground and substrate along the x-axis as well, right? So now you can observe that if you double click on the ground, you can just check its values along the positive x-axis, that you have simply provided the gap of 5 mm, right? If you remove that gap and just click on preview, then you can observe that that will be at the exactly end point where your patch is going to end, right? And if you notice the total gaps, so this is the 1 gap, 2, 3 and 4. There are 4 gaps and 4 substrates, right? You can say that 4 patches, and 1 gap plus 1 substrate or width of the patch is equivalent to the variable d. So that's why you can simply, if you simply add d here, then you can easily observe that this end point will approaches to that end point, right? Simply just click on preview and you can observe, right? So simply just by adding another d, you will approach to the end of the other patch, right? And in this way you will further keep adding the value of d, right? And lastly you will approach to the last point, right? So now you have to add some gap as well. So I have already added the gap of 5, so that's why now I have added the gap of 5 here, right? So simply just select and you can just copy this x max value for substrate as well, because you have to increase the size of substrate along x axis as well. So that's why you will simply add this gap in the substrate as well, right? So now we have designed our 8 elements array, and the last thing is that we have to define the port here. to just simulate that antenna. So we have already defined the port, and that port is not at exact location, so that's why I have deleted that port. And before assigning the port to these points, you can simply add all these points, right? So that's why I'm just going to add all the newly defined feed lines, right? So I will simply add all these values. So I have selected the patch, and from this I will simply add feed line 11 and feed line 12 as well as the patch 1, right? So and just I will press enter. Now all the values have been added, and you can just zoom it in and just rotate it to select the feed line point, and you can easily define the feed line. Just press the shortcut key F, and you will select the face of feed line. So go to simulation and just click on waveguide port, and as you know that along the x-axis you have to expand that feed line, and for that there is a formula that there will be an expansion of 3 times the width of feed line. So that's why I have just written 3 times the width of feed line here, right? So as far as its position along the ground is concerned, now we are at the top. So if I will simply subtract 1.6, it means that I have just moved toward the bottom position of the substrate, and I will use a positive sign, but minus plus will be equivalent to the minus, and I will simply subtract 0.035 to touch the bottom point of the ground as well, right? So that's why I have added these values. As far as the value of its height is concerned, then it is predefined that it must be equivalent to the 4 times the height of substrate, right? So that's why I have defined Z max is equivalent to the 4 times the height of substrate. So just click on preview and just click on OK. So you have properly defined the port for this 8 elements array, right? So just zoom it out, and now you can observe that your 8 elements array is ready, and now you have to just simulate it, right? So just click on start simulation. So as it is 8 elements array, so its simulation will take some time. So I will just wait for the simulations to complete, and then we will discuss about its results. Obviously 8 elements array will improve its gain, which is the basic purpose of designing arrays for microstrip patch antenna. So just wait, and we will check the results, and we will discuss about its results in a few minutes. Okay, so simulations have been completed. Now let's discuss about its results. First of all, check the S parameter results of this 8 elements array design, and S11 are equivalent to minus 10.938 at 2.45 or 2.4 gigahertz. So these S parameter results are quite satisfactory. However, you can improve the results as well. You need just little bit optimization to improve the S parameter results of this antenna, right? However, you can use it because the threshold is minus 10, and these results are below minus 10.9, right? So that's why S parameter results are quite satisfactory. Similarly, let's check the results of its gain, and it is now going to provide us the gain of 13.7 dBi. So you can notice that its gain has been improved while designing its 8 element array, and that was a basic purpose to design 8 elements array, as it was 10 point something in our 4 elements array, and now it is around about 13.7, right? So that was the basic purpose of designing 8 elements array, right? So that's all about the design and simulation of 8 elements array antenna in CST. If our video was helpful for you, then just like and subscribe our channel and press the bell icon for our latest videos as well. Thank you so much.